Okay, so there we go. All right, so we're picking up part 2 of our lecture about geology and the Earth's resources. In the first lecture, we were talking about rock and the resources. Again, what are the 3 major rock types? Classification of the 3 major rocks. Can you answer that question? Okay. If you can't do it right now, look it up, fill out the questions, or fill out the answers to that question. But those rocks are constantly moving around, and they're constantly changing. They're getting broken down into sediment. And rocks are a big part of the Earth's environment. How we get that stuff out leads to some significant environmental problems. So that's what we're going to talk about here is the extraction process. How do we get these things out of the Earth, and what are some of the problems associated with it? All right, so mining is very destructive to the Earth's environment. Mining, there's a lot of different ways to mine minerals and different resources. Usually, the problem is with mineral extraction. Let me put this in here. When you're doing mineral extraction, there's a lot of stuff that happens during that process. A lot of time you produce, that should be toxic. Toxic dust gets produced, different toxic gases, different chemical and sediment runoff occurs. And, all this stuff happens during the extraction process, and that leads to some serious problems. Keep in mind, when this stuff is the dust and the gases and runoff occurs, it's going into the watershed. So anything within that watershed, even if you're so many miles away, you're exposed to that toxic dust of the mine that is 7 miles from your house, or the runoff, or pollutants, etc. All right, so watershed is a big concern. That's why we look at watershed issues. All right, so when we talk about different general methods of extraction, first one here on the left-hand side, excuse me, is called open pit mining. This is where basically you're digging a big hole, and you're digging deeper and deeper and deeper, and notice kind of that swirling pattern, that circular swirl. The bowl gets narrower as you go down because you keep digging, and these things in here that look like little shelves, those are actually roads, and it's like this big giant corkscrew shaped hole that's being dug down into the earth, extracting the minerals as you go. Copper is mined in this fashion. The problem is water, rain, runoff, etc. goes into that pit, builds up high levels of toxic pollutants within the water, and now you have horrible environmental conditions. That pit gets abandoned after a while. Forget the copper mine. It's run out. We've played it out. There's nothing left in there that is of value, but you got a big giant hole in the earth. So that is an aerial view of a copper pit that is about 1.5 miles across at the top. That's your diameter. All those little things around it, those are homes. Those are houses down there that surround this. There's little woods here, more homes over here, etc. So you have people living in close proximity to an open pit. What are the pollutants associated with that? On the right-hand side, we're looking at strip mining. So you basically are ripping open the land, just cutting a big trough or strip through the land, digging out the coal as you go. Coal is the main thing mined in this format. So now you rip open the ground, you have so many feet or meters worth of soil you have to dig through to get down to the coal. You pile that dirt up, you keep digging deeper, now you find your coal, you scoop your coal out, but you got all this loose dirt, this massive amounts of loose dirt that runoff, sediment comes off of that pile, and it just creates this huge environmental catastrophe here to get to the seam of coal that is buried underneath the dirt. So not real good environmentally. Now granted, you can push all the dirt back into the hole, into the strip, but if you took out so much coal, now you have a depression. Is that the same as what it was before? No, you've not restored it back to its original ecosystem by any stretch of the imagination. Even worse than strip mining is what's called mountaintop removal. I mean, literally cutting the top of a mountain off. That's the picture on the left there. And that's an aerial photo where you literally cut the top of the mountain off to then expose the coal, to then extract coal easier. So, crazy. You know, all that exposed dirt, that exposed rock, all that stuff washes down into the nearby watershed, pollutes the streams, that gets carried into larger bodies of water, and just destroys the environment when you're ripping the top of a mountain off. Again, that's for coal. Now, on the right-hand side, we're looking at drilling. Drilling for gas and oil is one of the most common methods. Drill down into the earth, find that pocket of gas, tap it, funnel it, or contain it so as it comes up, it gets captured into your wellheads, and then divert it. Might not be as large of an ecological footprint, but it also has some significant environmental consequences. So fossil fuel extraction is unbelievably destructive to the environment. And that's why we're trying to encourage more people to recognize the value of renewable resources. Solar, hydroelectric, wind, and so on. Those don't have the environmental footprint, the damage that is associated with the extraction of things like coal and gas and oil. So, all right, now with metals. So we get the metals out, we extract the metals, and then often let me back up. We extract the ore, the rock that contains the metal. Then to get the metal, we often have to heat the ore to liquefy the metal, to then cool the metal into what we're looking at are little nuggets, these little blocks of, this is actually gold, these blocks of gold here. We have to heat it up, burn off all the non-valuable rock component to then get the metal extracted out of it. So you're heating it to an incredibly high temperature and producing a lot of toxic waste. That stuff often gets dumped in local streams, gets discharged out of the ore, or what they call smelting plant, and can lead to some significant environmental problems again. There's also a huge political and human cost to extraction with metal. In developing countries, child labor is unbelievable, that they use kids to go dig up these metals. And all of us in the developed world are part of this, because a lot of the metals those kids are digging up are used in the electronics that we have. So we can try to become more aware of what is the human cost of the new iPhone or my new laptop or any of the technology in those products we use. What is the political and human cost with the extraction of some of these? You know, a lot of those rare metals we're not finding and actually mining in the U.S. Those are coming out of developing countries. So some big problems. And then as we extract these metals and these minerals and these resources, we produce a lot of pollutant. The EPA estimated, let me get this number in here for you guys. The EPA is estimated we have, let me reduce that font. We have, this is in the U.S., their estimation is we have about 12,000 miles of polluted, or what they call impaired or contaminated streams due to mine drainage from different varieties of mines, copper mines, coal mines, etc. 12,000 miles of contaminated streams in the U.S. And to clean this up, they're estimating we have roughly 550,000 abandoned mines. And that comes at a cost of around $70 billion to clean and repair those abandoned mines. These are mines that are abandoned. Either they're on public land and nobody wants to do it anymore, the mines run out, but people are just like, I'm done with mining that. But there's still environmental pollutants there. There's still a lot of toxins and things like that associated with that abandoned mine. So huge ecological problems here. All right, so as we're doing this globally, because that's not just a U.S. unique thing, as we're doing this globally, we produce some significant pollutants. The top 4 global pollutants are lead, mercury, chromium, and arsenic. All of these things lead to significant health problems. They build up in the food chain. They are, we could call those pollutants that bioaccumulate and biomagnify. Think about what mercury does. It is horrible. And most of these are persistent, long-term pollutants. Okay, long-term pollutants in our environment, leaving some... Okay, so again, the connection here, let me pop a new slide in. The connection I want you guys to put together is how all this ties together. So resource demand. Resource demand is what leads to resource extraction. If I can spell this right. Which leads to environmental damage, destruction, I'm just going to say, etc. Let me go fix my typo. Alright, so all these things are connected. It's all linked. It's all tied together. So is there a way we can actually either decrease demand? Can we decrease the environmental destruction during the extraction process? What can we do to make this stuff more environmentally friendly? That is the goal with a lot of environmental science. Lower demand? Okay, maybe we can't. Modify resource extraction methods to be less environmentally damaging. Great. Or can we find ways to minimize and mitigate environmental damage and destruction? Restoration, things like that. Consider the laws that we have in place that hopefully protect us and keep things from being damaged and destroyed. Okay? So all things we want to consider and keep an eye on when we're looking at environmental issues here. So, all right, now some of the geological hazards that are happening are actually partially because of us. So let's take earthquakes. All right, so earthquakes are when the Earth's crust, those tectonic plates, move against each other. Usually they slide one past the other, and that creates that rumbling, rippling, shaking of the ground. But what we're seeing is that humans are actually influencing that. There's a lot of science showing humans are influencing the amount of earthquakes we have. So things like drilling wells. You're changing the nature of the crust, the tectonic plate. That influences the movement of the plate and how the water moves through the plate, things like that. In some practices, we do wastewater injection, where we actually drill a well and then push water into it that we're trying to dispose of. Wastewater from mining processes and mineral extraction. Well, let's just inject that down back into the Earth's crust. Well, that's kind of like lubricating the Earth's tectonic plates and making them slide around a little easier in some cases. All right, in the next lecture, we'll take a look at fracking and talk about that.